without being hurt by doing them. Does everybody know who that guy is? Raise your hand if you know who that guy is. Good, okay, then this story might actually be entertaining to a couple of people. So quickly about me, like I said, I'm a developer and security engineer at Haiku Studios in Atlanta, Georgia. I have a background in lots of things, mathematics, computer science, and some system security. I'm actually fairly new to web security. That came about by going to work for a web consultancy. Previously, network security was kind of my thing. And I've been a contributor to the Brakeman project since 2011. The Brakeman project is a static analysis security tool specifically for Ruby on Rails, which led me to the more general research we're going to talk about today. I've worked on lots of little patches and some false positive reduction tools for Brakeman. So this isn't a Rails talk, believe it or not. I am going to talk a great deal about Rails, but I'm going to try to use it as an example of what convention or configuration can do rather than what Rails can do. So really we're not talking about Ruby on Rails, but it does a lot of things right that help us to write secure applications. And we're going to talk about those things specifically. And those same things help us to reason automatically, programmatically about our programs. A lot of this comes down to there are a lot of codified calling conventions within the Rails framework that say the right way to do things. And this can be done in any language. It can be done in Python. It can be done in C and C++ and C#. It can be done in any language, but it's often not. So what do I mean by convention? Sensible defaults. And this not only means sensible default settings for your applications when you start running them, but also sensible default ways of performing standard programming idioms. We often, as developers, want to do the same things over and over and over, and we all do them a little bit differently, and we create lots of bugs that way. So by doing this, it allows developers to think less. We're supposed to be very, very, very smart as programmers and computer scientists, but every time we think, there's a chance for a mistake. The less we have to think, the less chance there is for a mistake. And the less we have to think about hard things, the better. And if we have to think about very few hard things, then seemingly intractable things might actually become tractable. Not always. This is definitely no silver bullet. There are still going to be difficult things. Otherwise, the computers would write the programs for us. But I use the frame convention over configuration. And there's a big contrast here. You don't want to just start, if you want to write a small web application, the last thing you want to do is write a gigantic XML configuration file as the first thing. You want to put a web app on the screen. So if you look at struts, if anyone's ever seen Java's struts framework, it's all XML configured, and it's kind of painful to start with, at least in my experience. And Python's Django is actually pretty cool, but it also gives a lot of leeway to developers, which essentially means no convention, lots of configuration. And that configuration may only be mental. It may only be in deciding how to put the pieces of your application together. But it's still lots of upfront work. So giving fewer knobs to turn allows us to do the right things the right way. And that makes life easier. And we do want to be able to dig deep and turn those knobs when we need to. When we've exhausted some resource, when we need more performance, when we need non-standard behavior, which we're going to in sufficiently complicated programs, we want to be able to do that. But we don't want to have to do that just to start running some code. So quickly, one of the reviewers of my paper said that not everyone would know what Ruby is. So let's do a little bit of talking about Ruby. It's a purely object-oriented language, meaning everything is an object. Unlike, for example, Java, where you have some primitives and you have objects, which is kind of awful. It's more like Smalltalk in that respect, from which it got its object model. It also unapologetically steals from Perl. The designer, Matz, loved Perl. He just wanted to write his own Perl. So you do on occasion get some strange variable names and some line noise. That's mostly been deprecated because it wasn't good, but that's where it came from. And it does steal a lot from Lisp conceptually, which is what drew me to the language, actually. There's this notion of duck typing. Duck typing comes from a bad pun, which is if it quacks like a duck, then it should act like a duck. So rather than saying, is this thing a string, I don't really care if this thing I've been handed is a string as long as I can print it out to the screen. It could be something very complicated that knows how to be printed. So that's what duck typing is. And it's got a very, very flexible syntax. Sometimes you can use parentheses, you can choose not to use parentheses. There's different ways to lay out lots of different program structures, which allows you to write what we call domain-specific languages, which I think we can write in many languages. But very often the domain-specific languages we write are to match some domain. You may have a text file that kind of looks like a program to you in your brain. You can make a Ruby program automatically parse that text file, for example. So what is Ruby on Rails? Quickly also, it's a convention over configuration model view controller framework for writing web applications, HTTP, HTTPS. But the reality is the web isn't what it used to be. It's not just putting cool web pages up and having MySpace and embedding MP3s. There are service-oriented architectures. There are JSON APIs. There are SOAP, XML APIs. And these are just API endpoints. And there's even new stuff like Hatios for MIME type controlling your API responses. Rails does a very good job of allowing you to write these as well as writing the old-fashioned just web applications. And it's a very complete stack. And literally a stack where they have many different layers of interaction, allowing you to hook and instrument, do performance work, do infrastructural work at very low levels for things that need to be very performant, and at very high levels for things that can be fairly abstract and can be fairly slow if need be. And what this gives us is a separation of concerns. It allows us to think about front-end interaction here. It allows us to think about data manipulation and data flow through the application here. It allows us to think about persistence of objects that need to be part of the system in a database perhaps here, and we don't have to combine them into one object. We can really separate them when we think. So, what is it under the hood? It's actually, like I said a moment ago, DSL, domain-specific language for writing these web applications. And it creates lots of magic methods. People who are first exposed to Ruby on Rails, particularly if they were exposed in the previous version, Rails 2, we are now in Rails 3, you saw lots of magic that occurred. There were these functions that you could call on objects that, if you looked in the source, didn't seem to exist. You would say, oh, find by name. Grep find by name didn't exist. Well, how does that happen? It turns out we have these magic methods, but they're extremely consistent in their naming structure, and they're all just method calls in the way that rather than functions, we have methods in Ruby. And they're all just method calls. So in this case, whenever we are using magic method, conventions are preferred over being clever. Being clever is any time you implement something yourself. Now, we all have to do that. There's times when we have to be clever in our code. But if the framework already does it for you, don't do it yourself. You can be clever when the framework doesn't do what you need to. So what is static analysis? That's what we're talking about in general. It's automatically reasoning about programs without actually executing the program. Analyzing programs by running them can give you lots of very valuable information. But the reality is, sometimes you don't want to. For example, you may want to talk about the program's correctness or optimization or find some bugs with it. But you may also not want to run the code because it's malware. So someone asked, how do you use this for malware? What if it's encrypted? What if it's got a complicated packer? What if it has all these different tools that malware authors will use? First off, lots of malware doesn't do that, which is kind of terrible. It should all use the obfuscation techniques. That makes them stronger malware. But also, at some point, it's only part of your stack to analyze malware. There's other reverse engineering tools you'll have to use to understand malware. But at a certain point, if you can automatically reason about behavior, then that will aid you in understanding the behavior of malware. And in dynamic languages, languages that don't necessarily have strong typing, like Python, like Ruby, we're going to analyze programs at the same level as the compiler. And I realize this isn't the same compiler we have for C and C++. We're not compiling down to machine code or assembly code. But we are generally compiling down to some variety of bytecode. In the Python virtual machine, there's actually a bytecode representation that then gets executed. In Ruby, there's a virtual machine that has its own opcode sets that do get run. And this is the level at which we can do static analysis in all dynamic languages. If we want to do it in Ruby, there's a few tools to do it. Really quickly, there's Rack, which is like Yak. It's a parser generator. You can use that to generate, you can use the grammar generated by Rack with Ruby parser to give you the abstract syntax tree that you'll want to analyze. And then there's this S-expression processor that allows you to write very concise abstract syntax tree parsers to move through the abstract syntax tree to find what is interesting. And nowadays, if you're really up to date, Ruby 1.9 has its own built-in reverse engineering abstract syntax tree generator. It's experimental and often broken, but it won't always be. And the Rubinius project also has one, which are handy. Python can do this too. There's actually Python language tools, which is in core. It provides all the tools you need to start analyzing Python programs automatically. But there's very little work on security. I've mostly seen correctness checks. And I believe PyFlakes also does some not only correctness checking, but also some kind of code smell checking, code duplication and things. So like I said, no security tools. But this is a hacker conference, right? So what about security? Classifying security vulnerabilities is hard. Very hard, I'd say. So I have trivial listed. I mean trivial. They're not necessarily trivial to exploit, but their root causes are fairly trivial. Cross-site scripting comes from trusting and outputting user data filtered insufficiently. SQL injection comes from using user input badly in a SQL query. Non-trivial exploits, there's a huge class of them. If you look at the OWASP list of top 10 web vulnerabilities, more than half of them are system configurations. Is your web server set up correctly? That's not what we're going to be talking about today. While that's very important to security of infrastructure, it's not a web application security layer that I worry about. Other things we can worry about, things living in the cloud, the permissions on your Amazon S3 buckets. If they're bad, you may have an immediate data leak. Even if everything in your application is good, you're storing your data in a place that's insecure. And sometimes these things can be chained together. Some data that a user stores can be pushed out to S3, which has bad permissions, which can be manipulated and brought back and turned into a cross-site scripting, for example. This is what we want. These are what we'd like to prevent in our web applications as much as possible. So there are some web application scanners. There's dynamic and runtime scanners that actually attack a running web application and try to actively exploit a SQL injection or actively inject cross-site scripting. And they're very good. If you haven't looked at Skipfish by Michael Zalewski, it's well worth investigating. Not only is he extremely hardcore, he writes C that analyzes the DOM directly, which is kind of scary, but he's that crazy brilliant. W3AF, everyone uses. It comes on Backtrack. Cool. Retina, it costs quite a bit, but is actually very good. We're going to be talking about these tools, static analysis tools specifically. For Rails, there's Brakeman, which is the project I work on. It was originally written by Justin Collins, President Beef, who's the co-author on the paper, and Neil Matano, both at Twitter. And there's lots of contributors now, including some at some big companies who I don't think I can name, but there's active work coming from the Ruby on Rails community, which is kind of cool. There's actually a very similar tool in some ways, Scanny, from the OpenSUSE team. Rather than using the grammar generated by Rack like we do, they generate their own grammars for Ruby on Rails and then parse those, or use those to parse applications. I haven't been able to dig too deeply because it's a very complicated architecture. This has enough of a complicated architecture that I have to keep this in my brain. I can't add one. So let's talk about actually using some static analysis and finding a bug. So I said this earlier, and I stand by it, but it's funny. Cross-site scripting is always trivial in that we're relying on user input in some way and we're outputting it, right? Is everyone familiar with cross-site scripting? If you're not, raise your hand. Awesome. One person. So this is going to be kind of important, and we can talk later. I'll explain it. So this is a bit of Ruby on Rails code. And I'll talk you through it very quickly because it's very easy. We have a controller from any model view controller architecture. It's going to take user input, process it in some way, get some data from the database, and then render some output for you. We have one thing it does, which is the index. So if you just go to application URL/users, it will automatically call index. And this has two more pieces of functionality. It has this before filter. What it does in Ruby on Rails is it automatically, before every action of the controller, calls that method. This is a Ruby symbol, get users. It calls get users. And all that does is goes to the database and says, get me all of the user objects. So, okay, so far, so good. We're using Ruby on Rails to get the user stuff. We're doing it automatically for every action. And we've got some method. The one subtlety, if you don't know Ruby on Rails, probably very few people, this will automatically also, at the end of the action, render the index view. So how does this turn into a cross-site scripting vulnerability? I've actually combined three files here. This is the index view. That's water being kicked. This is a user partial. It's just a small piece of view logic that we'll use again and again. And this is another one for their biography. So what happens here? Well, we have this render. We're going to say, all we're going to do is render another piece of code. Render the partial user, this file, with a collection of users. And this is some Rails magic. It automatically loops over this collection and renders this for each and every object there. So for every user, go out and show the user partial. And here we're just going to say, oh yeah, this is some stuff about the user. Render another partial, the bio, the biography, with some local variables. We'll call one of those local variables a user biography. And there's this raw user.bio. This will become important in a moment. And then all this does is goes out and renders this file where it just prints the user biography. So Dave Worth drinks too much beer. Fabian organizes cool conferences. Right? It just loops over all users. So there's not a lot going on, but these are in three separate files. And if we run Brakeman, we get this report. Oh, there's this unescaped model attribute. I've trimmed this report. It's usually actually so wide you can't see it in your terminal. So I've only used kind of the salient information. Well, okay, what does that mean? It points to this call to raw. Now, raw is almost a bad example, because what raw says is, please, this is a cross-site scripting vulnerability. In Rails, every time in a vulnerability we output, every time we output anything from the database, we automatically escape it. In Rails 3, that was not the case in Rails 2, and we'll go back to that in a moment. So this is almost contrived, because there's this point where it basically says, please make this a vulnerability right here. The reason this can be actually kind of subtle for an auditor is this partial might be used in lots and lots of different places. That's why we actually make this reusable by making it a separate little piece of code. And in some cases, this data may have already been certified to only contain valid information, non-cross-site scripting data, maybe not even user-controlled. Maybe we control that data entirely, but we want it to contain some scary data. Scary if a user controls it, but not scary if we control it. So in our case, it's not a vulnerability, but another developer comes along and does this. This gets them exploited instantaneously. That's not great. So in Rails 3, we assume all output is evil, and we escape it. Now, you could say, whoa, whoa, whoa. You know, cross-site scripting is a function of the renderer. It's on the client side, it's not on the server side. On the server side, you just have a string. On the client side, you produce some output, and then you run your JavaScript engine against the rendered DOM, and then the cross-site scripting occurs. So it really has nothing to do with you on the web server, but it is your responsibility to not give bad data to the users. I agree with that. What I will say is that, yeah, I'll leave the next. What I'll say about that is that if there's a vulnerability in the filter that Rails implements, where we attempt to escape everything as it goes back to the user, if there's a vulnerability there, it's not the developer's job using Rails to verify the correctness of Rails, of a framework. The framework's job is to do what it says, which is, I escape all HTML leaving, so it cannot contain a cross-site scripting vulnerability. If that's wrong, the developer has done their job. They've followed the contract with the framework. And so yes, cross-site scripting is subtle in that there may be ways that you can convince Internet Explorer version 8 to cross-site script with a certain string stored in the database because it was not being escaped correctly for Internet Explorer 8. But that's not the general case for cross-site scripting. The general case is we can escape it well, and we need to patch up either the escaping routine or Internet Explorer or both. So we make good assumptions that everything is evil when we escape it. Rails 2 does the exact opposite, actually. Rails 2 is very deprecated at this point, but there's lots of Rails 2 applications still out there. You may actually get called upon to audit one someday if you work for a security firm that does audits of web applications. And the difference there is that in Rails 2, it requires developers to mark strings as safe. This is a terrible idea. Asking anyone to make a priori claims about data in the database before they've received it is very dangerous. And you're asking developers to never make a mistake, to never forget to mark something correctly. So this is a convention over a configuration. In this case, we are always saying, we're going to do the right thing, and if you, the developer, want to shoot yourself in the foot, no problem, we'll let you do that, but we're going to do the right thing. In this case, it's configuration. Every single time the developer needs to remember, and this is not great. So this next slide makes some people angry, I think, because XKCD is not funny anymore. It's not funny anymore, although there is one XKCD t-shirt in the audience, so at least one person should be laughing right now. So someone said, well, you know, this isn't funny. We're security guys, and this is dead, right? I mean, this was 2008. We shouldn't be talking about this anymore. And you're absolutely right. We shouldn't be talking about this anymore. But we still have to. It still happens constantly in PHP, Ruby on Rails, in all sorts of frameworks. That's not great. So we need to talk about it. But I'm talking about static analysis. I'm not talking about specifically Rails techniques to mitigate, right? So why do we need static analysis? Why can't we just use grep? So yes, in a lot of cases you can use grep, and I won't lie, the case with raw in Rails 3 from the previous example is one place where you could use grep very effectively and be fine, because that's a smoking bullet. You can't actually do it so effectively in the Rails 2 case. Checking for the inverse is much harder, but you can in the Rails 3 case. But searching for SQL injections with grep is hard. You have to do what we kind of call semantic grep, which is you end up writing these complicated regular expressions which end up being components of parsers that have to repeatedly be run to find context to determine whether or not something is actually vulnerable, and that's awful. So, semantic grep is hard, vague. You end up checking really, obviously bad things can be determined, like I said, the case with raw, but checking for, and I should have made this better, this is the beginning of a string interpolation in Ruby. Checking for string interpolation, what I should say, isn't sufficient for SQL injection. Because there's times when a string interpolation in a SQL query string is completely valid. Like if I control the data. If I, within my control logic, make some decisions about the type of operators I want in my query, that's fine. It's the second that I allow any one of you to control my SQL string, this is awful, because it will end badly for me. So, for example, why is this insufficient? Here's two pieces of Rails code, both of which will match that string interpolation in a scope is basically a way of generating queries automatically. And in this case, we're taking a parameter, first name. In the first case, the name-like scope, we are generating a prepared statement. You can pass whatever you want into a prepared statement, right? This is a standard web best practice. Never let a user put data into a string. In the second case, we're actually interpolating the same name. This is the bad version of it. And these would both match the grep. Well, okay, maybe we can write a sufficient enough grep regular expression that starts far enough back in the context and works forward to make sure that there is a closing quote and some commas and you're in a new parameter. But that's awful. You're now using regular expressions to solve a problem that are, you're writing a parser in a regular expression, which is not correct, especially if your language isn't regular. So let's talk about convention or configuration. What does Rails do to help? And this can be done in any language. We have basically in every action exactly 3 places where user input lives, and they're named consistently. Params are all of the parameters from a post, from a get, if you actually include query parameters in the HTTP query. That's where they always live. You'll never get an HTTP query parameter from anywhere else. Cookies contains the cookie object. Well, that's pretty obvious, right? And it's stored server-side, but you could perhaps expose also user cookies, which would be a bad idea to trust any of those. And the request object contains headers, basically the entire body of a single HTTP request. These are the only three places that Rails, out of the box, hands you user input. So A, as a developer, you don't have to think hard about where user input comes from and what not to do with it, right? But you can also write tools that rely on that very well. So let's talk about just tracing some user input. Brakeman actually does this very well. Does anybody here know about Perl's taint checking? Raise your hand if you know about Perl's taint checking. So Perl's taint checking basically says if you take a string from a user and you run any regular expression against it, substituting anything in it, then that's now safe. You've made it magically safe. That you could actually replace nothing. You could say replace the empty string with the empty string. Perl says it's fine now. That does not happen with Brakeman. In this case, we've gotten some method that we have to store in the cookies. This is extremely contrived. I just wanted to use a non-param, so I wanted to use a different user input params variable. I take out everything that's not a lowercase value, and I even add something to it. So this is actually a fairly well sanitized method name I've just generated, and I actually send it off to the first user in the system. This should still be considered dangerous. Using send to call an arbitrary method should be scary in any language, right? Do you want a user to tell you what function to call? Probably not so much. But in a lot of frameworks, in the Perl world, for example, this would be considered safe. You've manipulated it, you've touched it, you've pulled things out, you've made sure that they're only the things you expect, and you've even added something to it to control it. Brakeman will determine that this is dangerous because it traverses the abstract syntax tree, back up, and finds the source of the original data is the cookies object. This comes right out of the Brakeman standard guide of what not to do. Perhaps you want to redirect somebody after you've saved some data to the database. You want to redirect them back to the home page. You just hand them an action. Well, the action will be indexed. That's the home page. The problem is redirect to is actually very, very powerful. This function can do all sorts of cool things. And if the user controls some of those things, including the host, you can redirect them to another site. So I can basically, it's equivalent to cross-site scripting, only I tell you what server to go to first, which is kind of scary. We can detect this as well because we can see that we're trusting the parameters variable in a redirect to. We know this is dangerous because this may contain a host key. And rather than checking, does it contain the host key, and saying, oh, it doesn't contain the host key, move on with their lives, which is difficult and must be done at runtime, we can flag this initially. So quickly, Ruby's libraries come in gems, and what that means that's just a name for a library, nothing very special. What we do try to do in the Ruby community is take all, if we have a gem that's specifically aimed at web applications, we want to make those gems follow the conventions of Rails. Why? The second you follow those conventions, A, developers are less likely to make mistakes with them, so they're less likely to create security vulnerabilities with them, and we can write tools that analyze them very naturally. So modern Rails apps rely on this thing called bundler, for example. This is what we're talking about. Bundler tells us how to keep the library dependencies in check. And the second you include one library that does image manipulation, it's going to have 500 other libraries that it needs. So it's a single DSL to do this. We use this to check for vulnerable versions of Rails and gems. Right? So we can quickly check, oh, your version of Rails is version 3.2.6, which has a cross-site scripting and a SQL injection vulnerability. Don't use that. We can warn based on that. And we're doing this not by parsing this as a string and checking for certain numbers, but because bundler happens to be a domain-specific language written in Rails, we're able to parse its parse tree and check the specific calls to various bundler methods and make sure that the version numbers are up to date with CVEs, for example. So we do this. We check for all the CVEs that come out of the Rails world, make sure that software is up to date, and we also really would like this, is that gems start having their own CVE list, but they don't. I'm going to skip that slide because it's useless. But again, this isn't about Rails. It really isn't. This is the exact same slide as before. And so it's a security conference. Let's talk about attacking web applications instead of securing them, because I suspect people are bored about hearing about Rails and Ruby on Rails. So yes, we should be talking about this. First thing is conventional configuration allows very precise auditing. Does anybody here do application auditing for fun? You should. All right, one person. Auditing is fun. Sometimes you can be paid for it. I get paid for it. It's great fun. When you know the ways that even a well-meaning developer are going to do dumb things, you can focus on those first. So rather than having to read every single view or every single line of every single model, which on some level sounds trivial, like, oh, how big can these apps be? Enormous. Most of Twitter is still written in Rails. There was this long time thing where Rails doesn't scale and it didn't work and Twitter was always down with the fail whale. And Rails has become much more performant, Ruby's gotten better, there's some other back-end tools to help them, and Twitter's a huge application, surprisingly, for 140 characters of display. So auditing every single line by hand and understanding the data dependencies manually is fairly difficult. Now, Thomas Potacek, who you mentioned, said, tools for code auditors basically blind you to the real bugs. I disagree with that, even though in general I agree with him. Tools for auditing allow you to focus on the meaty portions first. If you can find low-hanging fruit, do. If your tool finds nothing, then dig in manually. That's fine. So we can focus in using both convention of configuration as well as static analysis. By understanding these conventions, we can also attack those conventions. Oh, well, I know that the correct way to query the database in Ruby on Rails is in scopes. So look at the scopes. Oh, those scopes, by parsing either the AST or by looking, contain some variety of excuse me, string interpolation. That's bad. There's no magic bullet. Preparing for this talk, I found lots of ways in which my tools don't work, and that's kind of a bummer. So let's quickly talk about full stack MVC frameworks. By full stack, what I mean is this does everything. It handles everything from the time the web request comes in to goes down to some database probably, may hit some cloud services, puts everything back together and displays something to the user or responds with an API request. A good one is Django. It is a full stack framework. It's not MVC, it's MTV, which stands for Model Template View, where view is the controller. So that's kind of confusing. But you're immediately required to decide on your organization. There's no guidance at all. So that's kind of weird. If you want to focus on security layers, yeah, well, they do cool things. They have this persistence layer to prevent SQL injection via query sets. It works pretty well. The presentation layer does escaping, just like Rails does. Actually, Rails copied this from Django. And the request layer has an anti-cross-site request forgery token, but you have to remember to use it. This isn't great. So far, we have some tools to do the right thing. But in the same community, we have GreHack. GreHack claims to be a properly convention over configuration framework. It doesn't do any of the things it claims, which is disappointing because this is what I came to first. I didn't even think about Django because it doesn't claim to be a convention over configuration framework. It claims to just be a really great web framework, which it is. So there's no convention for user-controlled data in these actions. Now, if you have no idea where user input comes from in a given method, how do you reason about whether or not it's user-controlled? You don't, is the answer. You then have to immediately assume that every variable that you have coming into every method in the entire system is user-controlled, because you can't traverse otherwise. That's not great. Yeah, and like I said, if you're in a call tree, if you've got some huge function call tree, and you're way down here, you have to, every time you want to analyze the safety of a variable, traverse back up to where it came in. And that's very costly. So there's Grails. Grails is just an implementation of Rails in Groovy. Groovy is a dynamic language written in the JVM. It's actually pretty cool. If you really want to use the JVM and you really want to use Rails, this is one way you could do it. Because writing Ruby apps on JRuby is not always super awesome. And it has a static analysis engine. So since it's already doing all the things in Rails that are very conventional, that allow your tools to rely on conventions, there's a static analysis language or framework, you should be able to do all the things that Brakeman does. So quickly, micro-frameworks are a disaster for reasoning about your programs. Not because they're not good. They're actually really, really good. Flask is one you may be familiar with. It's in the Python world. Sinatra and Cuba. Cuba is new to me. Sinatra's been around for a long time. Basically, people use them to write API endpoints. They're extremely lightweight. They usually don't end up doing persistence. That's kind of the hard part. That's the part where lots of trouble it's where you get into lots of trouble. It's where cross-site scripting comes from, like type 2 cross-site scriptings, and it's where SQL injection comes in. So they skip that entirely. But it's this nice framework for quickly creating web applications. Yeah, that's true. And API inputs, like I said. And it doesn't do any of the active record, which is persistence layer stuff. And you get these little methods that define get and post, and they may be passed in multiple ways, but this is actually kind of cool. So one of the ways that Sinatra passes variables around is through a params hash that looks kind of familiar. It looks like Rails. Once again, we can say anything that comes from the params hash is tainted automatically. We can't trust it. Regrettably, they also give you enough rope to hang yourself. They give you this syntax, where n is the actual name coming from the URL, so you have to tie this back into this to figure out. Yeah, you know that everything that comes into the parameter block or into the block actually comes from here, so you shouldn't trust it, but it's not as conventional. And so writing a program to reason about this abstract syntax tree is actually much more difficult. We have to compare random names and make reasoning about where they came from. Were they introduced in the block rather than being introduced in a specific call like the parameters hash? So this is the part where it's basically a plea from me. Let's add conventions to make our applications more secure. So how do we do that? We have to identify boundaries. These are the security boundaries, right? You want to have a boundary between your database and your user input and the output, which comes from the controller layer. If you make those boundaries very explicit and very concrete and powerful enough that users don't bypass them, then we can, A, reason about them fairly reasonably. You know how all database queries are constructed, and you can focus your security work on those. And you're able to reason more carefully about data flow within the system because you know that everything enters through the controller, is argued about within the controller, is manipulated within the controller, passed down to the persistence layer, and then output through another layer. And these very careful boundaries allow us to make security decisions concretely. So if you also, when you're doing that, make those entry points and exit points consistent and powerful, when developers don't bypass them, they won't shoot themselves in the foot, intentionally or unintentionally. And you can lean on these methods to identify vulnerabilities as an auditor. You can, once again, always say, every time that you're going to enter the persistence layer, it will happen through these 3 entry points. So that's where I need to focus on corrupting the database. Or every time user output is going to be produced, it's going to come from these 3 methods within the views. So now that I'm almost out of time, I'm going to completely skip that since it doesn't do much for us, other than focus on, next slide. Focus on securing the interfaces between your layers. There you go.
Good time.
Yeah, check it out. Someone reviewed my slides and said I didn't have enough slides for 40 minutes. I think I overcompensated.
So we got time for at least 1 question, maybe 2. Are there any questions?
Sure. I'm not familiar with Ruby, but is it lexically scoped or dynamically scoped?
Depends on the version. And depends on the construct. So previously, it was there's a notion known as blocks, which is kind of our response to lambdas, where previously variables declared outside would not be side affected by the manipulation of those variable names within the scope. That changed in 1.9. So it depends. And that's an awful answer, right? Part of the problem with answering these kind of questions is there's actually no language specification for Ruby. There is a Ruby spec, and Ruby spec was written in Japanese originally, and it's never been translated to English. So the language creator actually, just says the definition of the language is my implementation. And so there are all these other implementations, like Rubinius, which is really cool, and JRuby, which actually differ in behaviors from the definitive one because there's no language spec. So but it's fun to hack in. It really is.
Any other questions?
Oh, I realized I was kind of light on actual static analysis details. That's intentional because looking at static analysis code is totally boring. But if anyone would like to corner me and or see it work and see what I do, I'll happily talk about it for way longer than you want me to.
Okay, thank you, Danny.